to our Innovative Discovery Series. As many of you know, the Innovative Discovery Series is sponsored by our NIH-funded program, the Delaware Accel Center for Translational Research, or CTR. I'm Claudine Jurkowitz, and I lead the Accel Biostatistics Epidemiology Research Design Core. I am very excited today because it is a presentation we've been looking for several months. We have three speakers, Dr. Leah Welty, Luke Rasmussen, and Eric Whitley, who will present an introduction to pragmatic reproducible research for translational science. Before I introduce our speakers, let me go over some housekeeping issues. We continue to provide CME credits. We will distribute the information via email to those who registered for today's event. If you did not register prior to today's talk, you can still obtain CME code information from Deborah Rees, and she will enter her email address in the chat box. Our next presentation will be on January 25th, although we are still trying to have someone in December, so stay tuned. But anyway, on January 25th, Jennifer Sims-Murtada from Christian Healthcare Breast Cancer Research Program will present her research from 11 to 12. So mark your calendar, January 25th, 11 to 12. So again, I am delighted to introduce our speakers today. First, Leah Welty. He's a professor of preventive medicine, psychiatric and behavioral sciences at Northwestern University. She's the director of the Biostatistics Collaboration Center, which is a Northwestern University Feinberg School of Medicine's Biostatistics Core for non-cancer research. She's also associate director of the NIH NCATS funded Northwestern University Clinical and Translational Science Institute, which is NewCats. She obtained a PhD in statistics from University of Chicago and did a postdoctoral fellowship in the Department of Biostatistics at Johns Hopkins Bloomberg School of Public Health. Luke Rasmussen is a senior clinical research associate at Northwestern University Feinberg School of Medicine. He obtained a Master in Science in Medical Informatics from Northwestern University. He's also Associate Editor for the Journal of the American Medical Informatics Association and has chaired multiple committees for the American Medical Informatics Association. And finally, Eric Whitley, he's an independent health informatics consultant who has over 25 years of experience in data architecture and systems design, specifically focusing on clinical quality and interoperability, and is a fellow of the American Medical Informatics Association. So all of them have numerous peer-reviewed publications, have been invited to write commentaries, and are sought-out speakers. So we are extremely lucky to have them today for our ADDIE series. Again, thank you, and we look forward to listening to your presentation.
Great, thanks, Claudine, and thanks, Deborah and everyone there for organizing our talk and our virtual visit today. This is really work we're very passionate about and we're very, very excited to share. So we were equally enthusiastic to get your invitation to present today and are really just delighted to be here. So yeah, you said the title, let's just get started. Thanks, Luke. So I want to go back a little bit to the history here and thinking about reproducibility and how this came about. And one of the ways it came about is in the 1980s, which feels like quite a long time ago now, there was a geoscientist at Stanford who realized that in his laboratory, which was very computational, his grad students and postdocs and research fellows had a huge amount of trouble reproducing their own work without considerable agony, which I like this quotation too, because I think many of us can probably identify with that experience, right? You do something, an analysis, a computation, you think you're going to remember it forever. You don't, and you go back to it and you're like, oh, what was I doing? How did I get this number? And this is really the origins of reproducible research, and it really lies in the inconvenience of doing things otherwise. So I really like to keep that in mind as we talk about this. It's, reproducibility and robust and rigorous science, certainly it's something we should all be doing, but ultimately I think it makes it easier to do science well. So I like to keep that in mind as we're talking about it. Next slide. So there's a lot of words that get thrown around with reproducibility. And so I want to sort of think a little bit about a definition and what it is and isn't. So people have probably heard a lot about open science. And the idea there is you can have open data, so data that's shared or publicly available. You can have open source software where people share all the inner workings of it. People can pre-register studies. You may have heard of things like the Open Science Framework. I think open science is wonderful. We live in a space where sometimes it's just not possible, right? We have a lot of PHI, a lot of PII. There are data sets we cannot share. And so I like to remind people that reproducible research can be disseminated openly, but just because something's open and available doesn't mean it's necessarily reproducible. Nor does it mean that if it's not open, it's not reproducible. We can still do reproducibility internally for ourselves. Another word that gets thrown out here is replication. And I find very much that depending on what specific area of science you're in, these words get exchanged. And so I think of replication as the idea or the chances that another experiment, another study will verify or achieve a consistent result. This is a definition that comes from an article in 2015 by Jeff Leake and Roger Pang. So for the vocabulary we use today, we're going to think of reproducibility as something a little different than replication. Replication is repeating a study and getting something the same. Reproducibility, we're talking really about within your own study. All right, so you've heard probably a lot of tools and software engineering things get thrown around, and we're going to talk a little bit about some of those today, but not in detail. Things like Jupyter notebooks or R Markdown or Docker containers. And there's a lot of software that can support reproducibility, but one of our points here is you don't have to be using those to make sure your research is reproducible. So certainly some of those tools can help, but they're not required. And the next part is scientific rigor. And that's separate too. Just because we can reproduce something doesn't mean that we're necessarily using the right methods or that we have high quality data. But as we'll see as we go along, being reproducible can really help us evaluate our methods. Next slide. Okay, so how do I think about reproducibility? If I think about the research pipeline, I've got a team, hopefully, that I'm working with. We have a research question. We collect or we gather some data that helps us address that question. We do an analysis. We hopefully write a manuscript. We disseminate it. We put those results out there. But then we really want to make sure that once we've done that, whatever's out there, we could get back to we can go back to the data and reproduce what's ever there. So we kind of know the entire provenance of everything we're putting out there in that manuscript or those presentations. So I really like this definition. We define reproducibility as the ability to recompute data analytic results given an observed data set and knowledge about the pipeline. So in my thinking, I want to use the same raw data and information about methods and choices to make sure I can recreate those results. And you can imagine what would happen if we didn't do that. What would happen if we went back and we reanalyzed our data, maybe the same way, maybe a different way, and we got something different? How do we know or believe the veracity of our findings then? Okay, next slide now. So then there's the ideal research world where everything goes in this nice linear pattern. And then there's the real research world, which I think everybody here lives in. And you know very well that people may come in and out of your research team, right? Research coordinators come and go, analysts come and go, maybe the person leading the project moves or transitions. And so you've got people coming in and out, but you've also got sort of this practice where you're going back. Maybe you're doing an analysis and you're like, wait, this just doesn't make sense. We think there's a problem with the data and you have to go back to the data and see what's going on. Or maybe you go to write the manuscript and you think, oh my gosh, wait, we have a bigger missing data problem than we thought. We need to go back and do some analysis to address this. And so in reality, there's a sort of recursive, somewhat messy process that can happen as we move from a research question all the way to trying to answer it and get an answer out there. So when we think about reproducibility today, we're going to think about reducing variation and managing change in the research process from sort of the end of the data collection period all the way through manuscript preparation and putting the results out there. Next slide. Okay, so to kind of provide another perspective on how this could happen, we have a research team who's working with data. Some people are doing analysis, somebody else is preparing a manuscript, and then we're trying to get it out there. So there's all sorts of places where we can start to ask questions about what is changing in the process and what do we need to manage. So for instance, the team might say, well, here's a table of results. Who produced it? What happened? Who do I go back to? Or where is the final data? Is this my final data? What version of software created those results? For those of you who work in informatics pipelines, or especially bioinformatics pipelines, sometimes software versions can change things a little bit, right? The operating system can change things a little bit, and that can create variation in your results. Manuscript, you're looking at a number there saying, wait, how did we get that particular estimate? What do I know about it? What are the covariates I've controlled for? What are the limits of its generalizability? There are pieces we need to know about that number. Dissemination. If we're in a position to be able to share things, our code and data, what pieces of it should we share and can we share to help other investigators with the process? So we've created some guides to this sort of approach to pragmatic reproducible research that we'll make sure are available to you all, and that there's sort of some worksheets and questions to ask yourself as you're setting up a project especially, or you're sort of evaluating a project to say, how can I make it more reproducible, or how can I address a certain problem I'm having? And we'll make sure these are circulated. Great, and that's the worksheet to go through. Some key points. We are firm believers in software is there to help, but it is not required. So we try very hard not to be sort of particularly entrenched with one software method or another, or say you have to use a Jupyter notebook, or you have to use R Markdown, or you have to use StatTag or something like that. You know, these are all great tools, but they're to help and are not required. There's no right or wrong way to do this. Projects have so much variability in how they're set up and conducted. There's just many approaches to it, and we want people to keep that in mind. Don't let anyone tech shame you. There's a lot of tech words that get thrown around out there, and we feel very strongly that that can sometimes discourage people from saying, you know, I want to explore the possibility of doing this in a different way, or, oh, I'm not, you know, trained in how to get, you know, Python and Anaconda on my computer particularly well. Is that going to mean I can't do this pipeline or this workflow in a particular way? Really, it's about tracking and accounting for change. That's sort of the fundamental philosophical approach we take. All right, finally, the hard truth. Like many things that are worth doing, there's an upfront investment in time, and we want to be very real about that. Kind of like eating your broccoli and Brussels sprouts. I personally love broccoli and Brussels sprouts. I'm not trying to malign them at all, but you know, sometimes that takes some convincing. Exercise, some people really love it, some people don't. Not everybody finds it fun. Car insurance is one of those things where you hope to never need, but gosh, when you need it, you're very glad you have it. So reproducibility is kind of the same way. There's an investment in thinking about it and working on it and working a group towards solutions and improving the practice. But some of that work goes in the beginning, but the payoff really is there at the end. When you can look back in code, let's say, that was written 4 or 5 years ago and say, oh, I know exactly where this came from. It's documented. I know where to find it. It's all here. Here's the answer. So we like to keep that in mind to still let people know. We think it's absolutely worth it. It makes for better science. It makes for more efficient, effective science, but it still takes some work on the front end. With that, I will hand it over to my colleague, Eric.
Hello. So following up on what Leah was talking about here, we don't really want to just take for granted that a study will be reproducible, but you sort of over time, using this analogy of plumbing, you just turn it on and you're expecting this water to come out. What you're not seeing is all the stuff that leads up to it. You're not seeing all of the participants, processes, and interactions they're used in producing your results. It's all very simple until you have to do it. Just don't take for granted that your study will by default be reproducible. Luke, could you go to the next slide, please? So let's take an example here. We really want to know, for the sake of reproducibility, who is involved, why they're involved, and then what activities the individuals are taking within your teams. Taking an example, let's say we're doing some sort of a phenotype development. You've got a data architect who's going to source some patient data, an ontologist who's going to map to data standards, a data engineer who's going to identify patients, statistics teams are going to analyze the data, and then a physician's going to interpret and report those. That's already a lot of individual processes, potentially a lot of individual interactions with the data, and a lot of handoffs. And each of those presents a challenge in being reproducible as you move data through a pipeline. If you have any variation within those interactions, you potentially aren't going to get the expected results or follow the expected process. Luke, could you change the next slide, please? And to talk about a little further about what Leah mentioned, each one of those individuals in their respective roles may use a different set of tooling. You're going to potentially have somebody who's using Java, another person who's using Python, another person with Python notebooks, another person with R. And frankly, you get to the end of the paper and you've got the individual publication you're writing that's going to have to take into account each of the potential data sets and products that are produced at each step along that way. Each is also going to come with their own disposition and how they like to interact with data and processes. So you may have a completely different mindset and set of individual skills beyond the actual tangible code between, let's say, the data engineer and the person who's a statistician. One is going to live and die by a particular method or a mode of interacting with data and may have different familiarity with other associated tools like version control, or there may be individual preferences that are going to come into play here in terms of how people like to store and manage their assets. Luke, could you do the next slide, please? So the key takeaways here are, you've got to really understand who's involved in your overall project. You've got to understand within the teams what the handoffs are going to look like. Are the roles and responsibilities clear within the organization so that we know who is going to do a specific task? What are the individual steps that they take? Are those understood by the other team members? So, we take for granted that you're going to come to a team member and magically just get some sort of product out of them. But is it really clear what they're doing? Do you know where their code is stored? If they go on vacation, you need to reproduce something. What's in their head that wasn't documented that is now no longer known by the project team? So with this idea of managing variation, the key is you've got to first identify the actual processes and have them commonly understood enough to be able to take that first step of managing them. You can't manage what is not known. And within that, you may sort of take for granted that you're going to keep it in your head. But the fact is we've all been there with this. We're going to come back in 12 months, 18 months. And even if you knew something inside and out, are you going to know it in the distant future when you're asked to reproduce those results? Future Luke knows what I'm talking about. Could you next slide, please? So we're not suggesting that, and Leah has mentioned this, you've got to find the right fit for what you're going to attempt to do here. We're not suggesting you be draconian when you're talking about actually instituting processes for reproducibility. We're suggesting you actually do the least amount necessary to ensure your work is reproducible. That's sort of the goal here, is it has to be right-sized. Going back to project management principles, when you've got a project, the goal is to be on time, on budget, and hit scope. You're not supposed to go above and you're not supposed to go below, because otherwise you're basically just wasting time and resources. What that means is you actually have control over finding what you believe is appropriate for your project and your team. And it's okay for those to change based off the project characteristics and the team capabilities. You've got to pick what's right for you. To one extreme, you may work with teams who are talking about fully automating everything within the pipeline. You hit a button and magically everything comes out consistently every time to the best of their knowledge. But on the other hand, there's nothing wrong with simply having conventions that may be applicable across your organization. Well, when we start a study, we're going to keep our assets in the following directory structure. When we version something, potentially we're just going to use a naming convention. Those are also perfectly applicable and actually can potentially be more beneficial for the right kinds of projects. You really just want to try to provide reproducibility so your methods match the complexity and risks of your project and the size of your team. If you're working with an FDA initiative, potentially you're going to want to have a lot more rigor and control over these things relative to potentially what you're going to do for an internal QI project. And that has nothing to do with the relative value of each of those initiatives. It may have to do the constraints of what's appropriate for regulatory consumption. Next slide, please. So going back to that, let's talk about some ideas here. We mentioned that there's a variety of dispositions and skills for your team, and that's really something you really want to embrace. You're going to have to understand what the capabilities are for your team and actually what their appropriate or personal preferences are with how they want to manage their work activities. You may have one set of tools that's right for one group and a different set of tools that's right for another group. So talking about the example of Luke and Leah and I all work together. When Luke and I are programming, we're going to use Git and, like extreme version control for the way that we manage our code. But when we're collaborating on individual assets like a publication, like this deck, for example, is, wherever it's called _v7, we keep it in a particular directory structure, and we always know that we have one person who's inside of it. Perfectly acceptable. The idea is you're going to find the right balance based off of the people involved, what's appropriate for use for their particular set of assets, and then frankly what the group can stomach. There's something that Leah said around not being tech shamed. That's a key takeaway here. Don't feel that reproducibility brings with it the burden of all of this technology. It doesn't. And in fact, it's counterproductive to do so because people, water and electricity, are going to find the easiest path. The more complex you make a process, the less likely people are going to be to follow it because frankly, they just may not be able to handle it. It may be entirely too confusing. I'm a developer and I see some of the things that people do with version control, and honestly, it's daunting. And I have to go back to documentation on how to manage version control processes that frankly, I find confusing and I can't always follow. If that's the case, what you're going to find is people are simply not going to either follow them intentionally or they're not going to be able to follow them. And what you're left with is lack of reproducibility. So a couple of the things that we've talked about here is you can do a couple of things. You can just have no explicit plan. That's always something you could do. We would suggest you probably not do that because that is kind of counterproductive with reproducibility. But then maybe for a particular thing, like you're going to store your assets on a file server, each one of them, the options you're going to come up with is going to have relative merits and challenges. And so what we would suggest, and this is some of the documentation that Leah had mentioned that we provide online, is to come up with those aspects of where they're going to drive your decision and choose the best course of action for your team as fits your project. Thank you, Luke. So maybe for images and data files, you're going to use a file server because frankly, you don't get any benefits out of using version control. And it's more of a challenge. And it also limits people who are going to do like graphic design in your group. For the manuscript, you may want to use something like a SharePoint. So you get implicit version control, but it's not something explicit like you're going to use for source control. And then for source code control, you may want something that's completely different, which is a much more atomic granular. You're branching the code. You're going to work it back in. You can have multiple people in there editing artifacts at the same time. Just make an informed decision, and you can mix and match and play to everybody's strengths. Next slide, please. So along those lines, one of the things that people talk about, it's sort of I think a misinterpretation of reproducibility is you have to jump right to automation. You don't. You absolutely don't. The idea here is that the process is known and that having it be known will help influence its ability to be reproducible. Automation can facilitate reproducibility, but you're going to have to ask yourself a key question. Is it worth it? Is the juice worth the squeeze is usually what we ask. And it can absolutely be that. But in some cases, what you may find is you automate something and you may not do it correctly and you no longer have the human intervention and control and it's sort of running blindly. Automation could potentially work against you with some of those things. What you probably want to do is figure out where it benefits your individual study and to work to automate those tasks which are frankly manually intensive and have a high degree of variation from a human's involvement, and to try to automate those. Those are totally worth it. But if you're talking about things like interpretation, where you're going to want to have somebody with a human subject involvement, or you're going to have something that potentially an individual can't automate, well, we have to log into this government site, access this data set, go ahead and download it, and then here's our workflow process we apply. That's basically human automation. Documentation can be that level of automation. The main thing is just to have the process be known, discoverable, and repeatable. Next slide, please, Luke. So along those lines, one of the things that people have really glommed onto here, because it really helps sew together a bunch of things. when you've got code and you've got publications and you've got interpretation of data and you've got, tables and charts and things you're putting together, it's kind of hard to sew those things together into sort of an easily visualized atomic linear whole. One of the things that's come out recently in the last 5-6 years has really been popularized is these notebooks, and there's a variety of them. There's several different data platforms that do them, but the idea is you have individual cells that have code, comments, visualizations, you name it, and you populate it with content. They run in a linear fashion, and it sort of gives you an implied automated view of what you're going to do with your data from the start to the end. And what that lets you do is sew together visualization of your workflow processes, as well as do embedded rich documentation. You can do some really nice documentation that says, here's what we're doing and here's why we're doing it, and I'm going to produce this data artifact. And then right in line, you can display what that data artifact looks like. And what's more, you can actually, with some of the cool technologies that are there, provide for interactivity of those data artifacts. You can do buttons that allow you to change a variable. You can actually provide interactive clicking on a graph and show the details and things like that without intervening in the actual workflow. The advantage there is the data and the processes are simply more discoverable and they're easier to digest, and that simplicity will promote reproducibility because it won't have to be something you fight against. You're not going to have to jump around with various documents. You're not going to have to hunt for comments you hope that someone, probably yourself, put into the code to help you come back at a later date and say, well, I can see what the code is doing, but what was I intending to do? Luke, could you go to the next slide, please? One of the other things it lets you do is there's nothing saying that you can't actually show the provenance in your work within that data pipeline, so you can actually see the unsuccessful paths that you took as well. I personally find this extremely helpful, so I can show, well, I tried to do this, it didn't quite work out, but we wanted to demonstrate what our rationale was for not showing this. You can still go through the standard data pipeline and produce all the artifacts, but what's helpful in here is you can actually show people a little bit more about what you elected to not do to influence the path you went down. And what you can also do is show a little bit more of that data exploration capability that I mentioned. So you can interact with the process a little bit and see it execute in such a way that it's much more tangible and discoverable to somebody. Could you go to the last slide, please, Luke? And along the idea that Leah mentioned too, we're now using all these varieties of software products, and especially as we start involving more and more people in studies, and let's be honest, studies are only getting bigger. You now have, I mentioned, we have the data scientist, the statistician, the ontologist, the data architect. You have a variety of different people, each using a variety of different tools. But let's say within those roles, you also now have somebody that says, well, I downloaded your code and I installed it and I ran your exact same pipeline and I got different results with the exact same source data. Well, how did those occur? Well, the fact is that at this point, what you also have is all of these little hidden differences, these hidden variations that really haven't been identified through your workflow process, because you sort of didn't necessarily feel that you had to talk about them. Well, we were using R3.5, not R4. Oh, we were using dplyr 1.13, which needs R3.5, and we were using a different version that has a different version of R. And now suddenly, unknown to you, you're getting different results. We actually have a individual reference that Leah and Luke highlight when we do this, the longer version of this talk, where we talk about an individual version of macOS going from one version to another actually produced different results because of the way integers were handled. These aren't things you necessarily anticipate or absolutely want to happen, but they're sort of things that happen over time naturally as you start talking about changes, not to your immediate tangible code, but to all those other magic dependencies that you didn't necessarily appreciate existed. Each and every one of those has the potential to alter results. So when we talk about reproducibility, one of the hallmarks of what we're trying to promote is simply being aware of all of the dependencies that are going to factor into your processes that you simply may not have been aware of. And I'm going to hand this over to Luke.
All right, thank you, Eric. Yeah, so I'm going to pivot a little bit now, or build on what Eric and Leah have talked about, to think about how do we manage this. What we've said and what we'll keep repeating is that we're trying to reduce variation And as Eric was talking about, one way to do that is simply by documenting. And so a piece of software that we have worked on to help address this in a pragmatic way is called StatWrap. It's free, open source, openly available. But what StatWrap aims to do is, and it works as well for a single team member. So if you're doing something by yourself, for large collaborative teams, but it works to help with collecting documentation, making use of the documentation that's naturally happening as part of processes that are going on through your data collection, your analysis, and the team coming and going, and give you a way to use that and leverage that information in a single place to ensure reproducibility and help you when you do need to reproduce your workflow. So here's an example of a StatWrap project. So you can create a new project in StatWrap and it can give you guidance about folder structure, for example, but it works as equally well if you have an existing project that you want to start managing and adding additional documentation to. StatWrap tries to be very hands-off. It passively will inventory the files, the assets that you have, and gives you opportunities to add additional documentation, trying to make that easy for you to do and account for variability, as Eric and Leah both said, just the variability in the people and the way that people like to work. So that flexibility is key. But once you've connected your project, so StatWrap will show you the list of all the assets. And again, we use assets, we're primarily talking about files and folders that most people think of, but we use the more general term assets just because there are other things that can be involved in your research project that could also be managed and tracked within StatWrap. But by passively scanning that, it can look and provide you additional types of filters that you might not have in your File Explorer program normally, to filter and organize your files and look through them. And the other thing too, and Eric's example of this presentation alone is a great one. So, some people work very well with naming conventions to indicate things. And so, but we all have too seen and know the joke about manuscript-final-revisions-final-LVR-submitted .docx, and that's not actually the one that got submitted. So sometimes naming conventions work and sometimes they don't. And so StatWrap offers an optional way to address that as well by giving you a way to enter notes and attach notes to the specific files. And that really can be anything. It can be something like, this is actually the version that was submitted to the journal, but it can also be additional information about, like, here is the data file that we actually used for the analysis. Don't use the latest updated one, because that's not actually the one that we wanted to use. The other thing that StatWrap is able to do when passively looking at the files is we can start to pull together the relationships and show you the relationships between data and code. So again, looking at your analytic files, we've got a listing here of different file types, as well as the different types of inputs and outputs, whether that's the data or like a library dependency. And then we can display this as a graphical map to show you how the files are connected. And in this example, we've got a Python file, we've got a couple Python files. We can see that these two Python files have some shared libraries. We can also see this Python file is reading in a CSV file and writing out a CSV file. So it provides us a way to explore what the code is doing, which can be very helpful, not only for you to understand what the code is doing a couple of years later, but also, as Leah was talking about, team members changing, somebody coming in and getting up to speed with the code itself. And then with all of that, being able to have this documentation. So the actions that you take in StatWrap, are being tracked within the log. But there's also, all of that other additional documentation. There's a README file that can be looked at. There's the notes that you can choose to annotate. And for those people who use Git for source control, all your commits that are done that's also a source of documentation. And so we want to centralize that. We want to make that easily accessible to show you a true timeline of all the changes that were done to help you understand the changes and the decisions made behind that. So in addition to all the activity in StatRep, StatRep has the ability to display, merge in and display all of the different get commit histories. So you have a comprehensive view. So moving on then from the analysis and kind of the overall management of the project, we'll go to this next phase, the creating the manuscripts, right? And manuscripts are mixed together with the data and the analysis. As Leah had showed early on, everything is connected and everything impacts another part of the step. So if the data changes, not only might you have to rerun your analysis and update your manuscript, your data might change in a way that causes you to rethink your analysis or conduct new analyses. So all of these changes along the way impact what you eventually put in your manuscript, and making sure that you're aware of those changes so that you can update something like a manuscript accordingly. But when we think about working with a manuscript, especially when we have a team of people, collaborative research, team science is very, very powerful and used quite frequently. There's additional considerations too. How do we be reproducible when the changes are so tightly coupled? By that we mean, think of a single manuscript file. We have somebody, maybe myself, who's focused on writing the narrative. And then we have someone like Leah, who's the biostatistician, who is working on the analysis and is putting together the numeric results that need to get put into the final manuscript. And maybe someone like Eric, who's also working on the data, but is maybe focused on developing the figures for them. So we all have different parts and we're all trying to work on the same file. We might not necessarily even know too what the other one is doing. And there's a lot of tools, of course, that can help with this. So my collaborators like to work in Microsoft Word. I'm a software developer. I like to work in Microsoft Word, and why not, right? It's ubiquitous, but it has really nice features, right? And for being able to do your editing and see your editing changes in the formatting, but also from the collaborative nature of the tracking changes, being able to add comments. And the reality too is many high profile, high impact journals definitely allow you to submit Word documents for your manuscript. Some of them require you to submit a Word document as a manuscript. But we do have, and so this is with our Markdown Jupyter notebooks. These are the same things that Eric was referring to before. Okay, so he was talking about it maybe more in the primary analysis standpoint, but the same technology can actually be used and is used by many people, including statisticians as an example, might be a group that's more in line to use this for actually producing the final manuscript. And so this idea of having your narrative text, your paragraph text mixed in with the code that generates the numbers, it creates what we call a dynamic document. The beauty of this is that whenever your code changes, data changes or whatever, you rerun it. This is one of those things that's one of those one button clicks that Eric had talked about, and it can produce a PDF or a Word document version that's beautifully formatted, reads and looks like a regular manuscript. And that's wonderful. But what do we do when my collaborators don't want to use our Markdown? They don't want to be working in a text editor. They don't like markup because they can't actually see that something is supposed to be bold. And they miss the ability to add a quick comment or to have the track changes. So they might not want to work with that. Well, I can generate a Word document for this manuscript and send it to them. But what's going to happen? They're going to mark it up. They're going to use Word to its full potential, mark it up, and send it back. So now I have two options. I can either go back and transcribe all of their changes back into our Markdown, or we can just abandon our Markdown. And it's a tool that can facilitate reproducible research because you have that ability to reconstruct everything very quickly and easily. But we could just also throw that away and just manually copy and paste numbers from the results into the Word document and just work in Word from there. But that's, of course, error prone and inefficient. And this is just the reality too of working with these teams, and it's not specific to dynamic documents, but I think it's one example that Leah, Eric, and I, and maybe many of you can relate to, that there's additional challenges with the benefits that exist with using our Markdown Jupyter notebooks and other technologies that support dynamic documents. There's challenges. And to reiterate what Eric was saying about is the juice worth the squeeze, there is the broccoli and Brussels sprout and an exercise moment for getting an R Markdown document set up and put together the way it needs to be. Maybe the reality is it's just quicker for that 250 word abstract just to write it out, copy and paste the 2 numbers that you need and put that into a Word document. And that's okay. So along those lines, and again, we've been trying to assess what's out there, realizing that tools are moving towards a more pragmatic standpoint. But one gap that we had identified for the manuscript preparation was around this idea of how do we utilize Word where Word is really what people prefer. And so we developed, this is another free open source software called StatTag that creates a link between the Word document and one or more statistical programs. So we do support R Markdown, StataSASS, Python, and not only can you link more than one statistical file to a Word document to have that effect of like the dynamic document, but you can also mix and match different technologies. And this helps as well when we think about the workflow of editing, because these things are separate. The code files are separate. So going back to that example, I've got the Word document and I can work on it in isolation, focusing on the text or getting the references up to date. Meanwhile, Leah is working on finishing up the analysis or conducting a new analysis in her Stata code. So she's got do files that need to get linked in. And Eric is working on some beautiful figures that he's been doing in R. So we have all those, we can put those all together. And then what StatTag does with a few clicks is it allows you to have annotated, and given the name, we put tags, we call them tags. So you have your tags mixed in within your text. And with a few clicks, you can just re-update and refresh everything. And because it's linked to Leah's do file or do files, Eric's R file, once we get these files back in the same spot, we just run it and everything magically works. But as with many tools too, this is not a slam dunk either, right? Hearing this, some of you may also be thinking, I don't use Word, I use Google Docs, or I do all my editing in SharePoint. So this is just another example of a tool that exists that can work for different teams depending on their workflow, or for individuals as well. So after now that we've got the manuscript done, we'll finish by talking about the dissemination phase of things. And again, just speaking very broadly, that we've got, we're just making things available. And when we're talking about artifacts, again, very general term that can really mean anything. It can be your data, your code, your documentation, your manuscripts. The important thing here that we'll start with, and we'll go through a few caveats and gotchas that can happen too, even when considering reproducibility, is it's important to have a plan, having a plan in place. And as people are getting more familiar with NIH's updates to the data management and sharing plan, maybe this isn't as much of a concern that folks have anymore. But when we think about reproducible research and what Leah was introducing us to, that this isn't the same as open science, I think it's important too, when thinking about dissemination and documentation and planning, is that you're not expected to share every piece of this along the way. And that's an important consideration. So if we have this hypothetical example where we've got data maybe from your CRF forms for a clinical trial, maybe your some medical record data, maybe some sensor data that's all being collected, and then we've got a reproducible script. Again, it doesn't have to be automated, but maybe it is, that creates your main analytic data set. And then you've got sub-analyses that take place for multiple different manuscripts. And so we have this is our constellation of all the different artifacts that exist. And so thinking about dissemination matters based off the audience. And this may sound counterintuitive, or this may sound obvious, but we disseminate to ourselves, to our team, to our future selves. So it is important to think about our teams and ourselves when we're thinking about future dissemination, because all of the pieces that went into our research along the way are things that we need to have reproducible, and that we need to be able to reproduce this in the future. Of course, dissemination, we probably most often think about making things available as part of our manuscript, whether that's, and it depends, depending on the manuscript and the type of data, but maybe it is your analytic script, de-identified data set, and the manuscript file itself that is being provided via the journal website, or other repositories, public repositories. And then there's kind of these new considerations too about, we've had all these things planned for how we were going to disseminate, and something new comes along. This maybe isn't the best example of something new, because here we say, well, we were planning to do it, but maybe we forgot that we have to create another copy of this data set and get it ready for availability within a general access repository. But thinking too about dissemination, that not everything is necessarily going to be fully open and freely available, but that there are new things that are going to pop up that we have to make sure are reproducible to be adherent with our dissemination plans. But we're going to turn and focus more on the more typical example of the manuscript. Okay, so we've done this research using this hypothetical example that we've talked about, and so we've got, you know, the data set that we've been doing the analysis that's created our manuscript. Everything is now perfect. Peer review is complete, and it's time to publish. And as we all know, how long does peer review take, right? The back and forth cycle. It's not days, right? Maybe if we're weeks, it's lucky. It's usually months, can be a year. But the fact is that, you know, time passes, that you've created this data set, this analysis code, and this manuscript, and time has passed since then. So what if we were being really reproducible? Let's say that we were taking it to the extreme of what Eric was talking about with automation, and that we have that larger data set that we're then running a script on to create a smaller data set specific for our analysis. Well, I mean, that's very great and very useful and helpful, but remember I said that a lot of time may have passed since we generated this and got it ready for the paper. So how do we know, though, that the data source hasn't changed? What if Leah is in charge of the manuscript and she doesn't realize that I went through and refreshed some of the data, and she also doesn't realize that Eric reran our entire pipeline, which actually overwrote the original dataset CSV file? So this is actually where reproducibility can catch you if you're not thinking and planning appropriately ahead. But the beauty of it too is there's very easy non-technical solutions. It can be as simple as modifying this script so that, you know, it has a unique name every time, and it's guaranteed never to overwrite the file, so you don't have to worry about that. Likewise, when Leah's preparing the manuscript, she could just copy, paste it into a separate segregated folder, mark the files as read-only. It's easy ways to address that, but it does require that foresight and planning. And then finally, thinking of reproducibility, not just for us too, but for the people who are out there that we're disseminating and sharing these things with, we have to think about how we're disseminating, storing, archiving things. So let's say we've released now this data set analysis and manuscript, and that we've collected more data. And because we are good scientific citizens, we've refreshed the data set and we immediately made it available, which sounds great. And we're also, maybe I'm testing out some new machine learning approach, and so I'm messing around with the analytic code and adding new stuff, but maybe accidentally adding a bug to the existing analysis code. All this to say that, you know, a year from now in 2024, when somebody comes along, if we've updated the data set, if we've updated the analytic code file, they're not going to be able to reproduce our original manuscript just because of the way that we've not really managed the files in a reproducible manner. And again, to say very simple solutions that many of you may have already jumped to is simply by having good versioning. And this could be as simple as putting everything into, you know, a single zip file or something like that. but explicitly versioning that this data set analysis and manuscript, that's what is with the publication. So that version 2, which may include that updated data set, you can have that as its own version. And of course, too, because documentation is low-hanging fruit, it takes discipline to do, but it's relatively easy once you build that habit to add additional documentation about, well, here's what's changed in that data set. Likewise, with if we want to additionally modify the analytics script, that we can just put in a note and maybe even say too, hey, this is in progress, but it's work underway. Using this approach, because we've thought about it and planned for it, when somebody comes around a year later, it's relatively trivial for them to know version 1 is the version of all the artifacts that they should be using to reproduce exactly the manuscript, and we made it easy for them. So in summary, reproducibility as a whole, as we said, is about accounting for variation and change, thinking pragmatically about it. We've talked about software tools, and we think software tools, they can help, but they're not required. And there certainly is no requirement that you're using any of these to be conducting good reproducible research. Feel free to be doing this just for you. We focus a lot as well on the team science, which is very important, but there's a lot to say for somebody, even if you're part of the team and you're doing reproducible research practices just for yourself. And even though the research process, as Leah had shown, we know that it's long, lengthy with iterations back and forth, you don't have to commit to being fully reproducible, fully automatic along the whole way. You can start small. You can start at various parts and just start to build more of those habits over time. So with that, in addition to Leah, Eric, and myself, I want to acknowledge our colleague, Abby Baldridge, who's been instrumental to all the work that we've talked about today. I have a few references. I'd like to thank the CTSA or NUCATS for the funding that led to this work. And with that, I think we have time left a little bit. I went a little over. I apologize for some questions, but thank you all as well.
Oh, thank you so much for this fabulous talk. And I mean, there are so many things that we experience all the time. That's, it's a life of a researcher, and I think you gave us wonderful tricks. I think there is a question in the chat from David Chen. StatRap looks really powerful. How does it compare with some things like CurveNote?
Go ahead, Leah.
Oh, I was going to say, I think there are slightly different spaces, and Luke, I want to hear what your take on this too, of course. CurveNote, I think, is a little bit more about the writing process of things and disseminating and collaborating in the technical writing process. StatRap is less about that. It's more like it just sits on top of the files and where they are, and you can document pieces as actively or just passively if you want to. So it's kind of doing a little more automated discovery of your files and what's there, and letting you filter the files and see how they're connected and add notes. It's not really about writing collaboratively, which I think is more CurveNote's focus. But Luke, go ahead.
No, you nailed it. I have nothing to add.
Okay. And I, not to say anything, I mean, CurveNote's great too, right? I mean, incredibly fabulous, very cool. Maybe it's a nice space to live where you're not living in Word, but you don't have to live in, the markdown environment that's not as pretty for people to write in. So it may be a really nice solution there for some teams, right? To say, like, we can do this technical writing, we can see what's going on with our changes. So it's kind of this nice in-between space.
Thank you. Any other question from the audience? Well, I have a question, meanwhile. See, the last part that you talked about, Luke, the dissemination, is this also, can you also handle it through StatRap? Or how does it work?
Yeah, so do you mean how does like the process of the Yeah. So I would say from the StatRap perspective specifically, like we don't have anything integrated within StatRap today that facilitates that, but that is certainly something that could be added to it, because the guidance, the practical guidance that we gave, those are things that can be automated, right? And so that's, as we're continuing to build, StatRep is available, but we're open to feedback and looking to enhance features, is something I think that we would like to look at. How do we produce a reproducibility report that can go with specific versions of the artifacts, and to aid that process, just to make the right thing the easy thing.
Thank you. Any other questions? So do you have a, and I'm very intrigued by StatRap. So I really, I don't know anything about this, but I'm very intrigued, and I've lived through, the version control and the data that change and the analysis that we need to redo. And anyway, so do you, are they within your team, is everyone using StatRap, or how is this? What are the comments that people have, so those who use it?
I think we're varied still. We're still in the early stages of rolling it out. And so we've had some early adopters who give us feedback about the places they find us most useful. I think it's one of the places I find it useful is when I'm working on something like maybe a project, like a smaller consulting project where I may be working on it a little bit with one of our master's level analysts, and we're both doing things in there. And I kind of just want to go in and see what's been done or what's been documented. And we're kind of playing some tag team. That can be really, really helpful. As Luke mentioned, I also just find it helpful myself. Let's suppose sometimes I have to go into a folder or a file or code for a project I never worked on, but somebody's coming back and asking questions about. Sometimes I will open it up in StatRap just so I can get that map of how the code files all connect to each other. And rather than having to go into those individual code files themselves and say like, okay, this one reads this one and this one goes here and it outputs to this, I get all those connections otherwise, and then I can start to navigate something that's quite old. So I've used it in that context as well. Now, Luke, I know you use it a lot for then like a pretty large coordinated cohort study too. So maybe you want to address that.
I do, and guess what? I'm the only one that's using it, right? But that's okay. I mean, I introduce it to the team. I make sure to promote it and show folks. But we make it work within the workflow. Folks know how I'm approaching get for version control and reproducible research, and so we find ways to modify our workflows and adjust with that.
And I think that's actually one of the things we designed for with the tool, is that it's sort of your co-pilot that's optional to help you. It's not a mandatory thing. So the design decision early on was that it just ran separately, but we used the file system as being where all the assets lived, knowing that people liked to use the file system. Now, there's a bunch of challenges to all of that, right? But the idea was, if people just want to put stuff in the file system, that's cool. StatRap still functions by reading those assets and giving you a bit of a roadmap behind those things, as well as telling you about the changes that occurred over time. That's one of the things we sort of, and I think we're still doing this, Luke, like I don't know where we stand on the deployment of this, but like transparent Git integration so that people who refuse to use source control, guess what? You sort of get it for free. They just don't even know it's there, which is part of the benefit. We don't want it to be in your face, because for some people, it's one of those barriers to using it. It's there for the people who use it. So it's okay that Luke is the only person using it on the project. Guess what? Everybody clandestinely benefits from it.
I see.
And I would say too, we're still in the earlier phases of rolling StatRap out. StatTag is much more mature. We have a big users guide. We have multiple releases. It's been around for quite a bit longer. StatRap is still new, so if anybody here chooses to adopt it and use it and has feedback for us, we are super responsive to that. We love feedback, right? We're sort of developing software in this little CTSA world where we don't have, big amounts of user testing. We can send it out there and get feedback, or like a usability focus group or anything like that we can do very formally. So we love to have feedback from people who decide to adopt or use, or for people who give it a try and they're like, it doesn't work for me and this is why. That's very, very helpful for us to think about other software, or if we can improve this software. If it's just not a problem we're able to solve, but we recognize that it's a problem that exists, it's really helpful for us. And I think that last slide has an email we monitor, as well as the website information.
Oh, this is great. I'm sure we'll work on it. I'm very excited. So will your slides be available? Because I think, I mean, there are so many documents that I think we should, we should look into and check and mostly the plan, for your documents, the first documents on the guide to reproducible research, I think would be really helpful for most of us.
Yes, yeah, absolutely. They'll be available.
Okay, great. All right. Well, it's already 1:02. Thank you so much for this wonderful, wonderful presentation. I don't think there are anything else in the chat. Let me check. No. And we'll keep